Welcome again. Today I want to take a look at the periodic table. It's the first in our series that deals with trends in the periodic table. The periodic table in its development was largely responsible for the work of Dmitri Mendeleev. Mendeleev believed that at the core of chemistry was an underlying organization of the elements. He was also a teacher and sought a means to invent some sort of device that could allow his students to understand chemistry better and look at patterns that emerged. And hence he came up with the periodic table. He believed that if one was to organize the elements in order of increasing atomic mass, their properties would repeat. Now that's not quite correct, because if you take a look at the current periodic table here at the elements, say cobalt and nickel, he would have reversed their order. He would have believed that nickel should come before cobalt. And likewise, tellurium and iodine, also in the periodic table, elements 52 and 53, they would have been in reversed positions. At his time, he didn't know about protons, neutrons, and electrons. That didn't come until the turn of the century. So now the organization of the periodic table is organized not in order of increasing atomic mass, but in increasing atomic number, the number of protons in the periodic table. There are also some other designs of the periodic table. Here's a more current one that takes a look at some of the orbital theories that we've mentioned. And here's a somewhat bizarre looking table that also seeks to organize them in somewhat of a sequential pattern. Let's take a little bit more at the organization and layout of the periodic table. To begin with, the blocks in the periodic table are based on the sublevels, the s orbitals, the p's, the d's, and the f orbitals. Over on the far left-hand column, we have two columns, and those particular elements all finish S1 and S2. It's worth mentioning here that helium could be moved over to fill in that 1s2 block. Our P block going from P1 to P6 over on the right-hand side. In the center of the table, we have our elements that go from D1 to D10, the D block of the periodic table. You might recall that chromium and copper don't quite follow this sequence. There actually isn't a D4 or a D9. An electron is promoted from a lower energy level, the S, up into the D to make it half filled. And finally, at the bottom of the periodic table, we have our F block going from F1 to F14. This allows us to very quickly come up with the electron configuration of elements. So for instance, if I want to know the electron configuration of zirconium, you might recall I back up to the nearest noble gas, which in this case would be the element krypton. Now beginning at krypton, I can then fill up the electrons. Krypton having 36 electrons and zirconium 40, I need to find the home for 4 electrons. So beginning at zirconium, I would put 2 of them in the 5s and the next 2 in the 4d. Let's also try bromine. Bromine in the periodic table, if I again back up to the nearest block, I come to argon. And beginning then at argon, I would put 2 electrons into the 4s. I would put electrons then into the 3d, all 10 of them, and the remaining 5 in the 4p. So again, the periodic table is useful with coming up with the electron configurations of my elements. The table consists of 18 columns, or 18 groups. And also, on the other side of the periodic table, we have what are called the periods, or the rows. The period gives me an idea of the highest energy level that the valence electrons are located at. So for instance, the element zirconium, being in the 5th period, I know its valence electrons lie in the 5th energy level. Similarly, bromine in the periodic table, in the 4th row, its valence electrons lie in the 4 orbitals, and here I've circled them. If we were asked to identify the location of, say, an element phosphorus, we would say that it is in group 15 and period 3. There are also some groups or families that we should be particularly familiar with as we move through this unit, and also the organization in terms of the properties. So let's begin with metals. Metals exist on the far left side of the periodic table. These tend to have luster, gray, silvery in color, conductors of heat and electricity. Our nonmetals, on the other hand, reside over on the right-hand side of the periodic table. They come in a variety of states, solid, liquids, and gases. They tend to be brittle, very poor conductors of heat and electricity. And dividing the two, we have a division that are called the metalloids, here outlined in blue. They exhibit physical properties which resemble the metals, yet chemically they behave more like the nonmetals and sort of exist as a transition between the two. As I mentioned, there's some groups we need to be familiar with. So beginning on the far left side, finishing S1, we have the alkali metals. Now, hydrogen would not be considered an alkali metal. The halogens, and finally the noble gases. That center block is called the transition metals, and remember that that also corresponds to the D block of our elements. And here the F block are sometimes referred to as the rare earth metals. Now each row is actually given a further designation. The top row are called the lanthanides. You can see where that name originates by looking up at the periodic table. The element 57 is lanthanum, and hence the first element in the lanthanides. And likewise, actinium forms the actinoids. So I hope you found that useful. Please post questions if you have any, and see you later.